Vamos! Let's get it!
Nice stuff.
Damn, bro. It's getting a little bit hot in here. You want to turn on your AC, please?
Yeah, I got you, man.
Thanks, G.
You're
struggling over there.
That's too far, bro.
Shit, you ain't got one of those Alexa ACs?
Nah, bro, I don't got a smart AC.
Dang, I'm surprised, Mike. Come on.
Nah, but you know what?
What?
I can make one.
Shit, I bet. Let's get it.
We can make a smart AC.
Hey, you already know what it is. It's your boy Mike. First YouTube video in a long time, so I'm gonna hop right into it. Today we're gonna turn my AC, my dumb AC, into a smart AC. I'm a believer in tech and AI, automation, home automation, but my ability to apply these things is pretty limited because I'm a renter. I live in an apartment. I can't control what kind of thermostat I have. I can't control the fact that I don't have central air. I can't change my lock into a smart lock. All I have are some smart lights, a couple LED strips, and a smart TV that I can all control with my Google Home. This bothers me, but the one that bothers me the most is the AC. Because while people associate Minnesota with cold winters, rightfully so, we have hot summers. I mean, it'd be baking here in the summers, you know what I mean? My vision's like when I'm on my way home, I can turn on my AC, and by the time I'm home, the place is cool. That's what I want. Is that too much to ask for? So my first thought, I mean, the lowest hanging fruit was to just get some smart plugs. Unfortunately, the type of outlet that this uses isn't the standard one. I could have looked a little more, but I didn't really want to because I wanted to do this manually. My second thought was, okay, I can open up the unit and see if I can get an Arduino to trigger the internal functions. But I quickly decided I'm not gonna open up this high voltage appliance with my lack of electrical knowledge. That just sounded like a death wish. So I was like, no. What I ultimately decided to do is utilize what I already had. I had a remote control for this unit. So I decided I'm gonna take that and expand its functionality. Here's how we're gonna do this. We're gonna use an Arduino microcontroller. Arduino is a platform that enables folks like you and I who aren't electrical engineers or don't have a deep computer engineering background to do some programming. People make robots and all sorts of cool things with it. On the hardware side, first you need an Arduino. I decided to use the NodeMCU microcontroller. That's a third-party one. I picked it because it's widely supported and it has built-in Wi-Fi. Second, I got this kit from Amazon. This has jumper cables, breadboards, power units, a lot of sensors and stuff like that. I did end up getting my own breadboards because the one that was provided was just trash. On the software side, we're gonna be using three things. One is Adafruit.com. This is where our button will live. This is where we'll trigger it from. Then we need the Arduino IDE installed on our computer to write and upload the code to our microcontroller. Then we're gonna use IFTTT.com to link our button with Alexa or Google Home or Siri or Home Assistant or whatever you use. What's Microsoft's called? Cortana? Does anyone use Cortana? First, I had to take apart the remote to just look at it and understand it better and try to figure out what was going on in there. Don't nobody tell my landlord about this. Jeff and I will sort this out later because I'm gonna need that deposit back. Now, right away, I noticed on every button, there was this inner circle and an outer ring. My hypothesis was that connecting the two would close the circuit and trigger the button. I tested this and I was right. Now I understood how these buttons are fired. The right way to do this is there's probably a way to connect the microcontroller on the remote with the Arduino and therefore control everything on the remote. But that's way too advanced for me. I wouldn't even know where to start. So I decided to sacrifice all the buttons on the remote except the power button, because that's what I really needed. To do this, I decided to close the loop permanently. I put some wire and taped it up. I'm using clear tape here, but I did use electrical tape later. My hypothesis was that anytime you attach the battery, the remote will fire. Then you can take the battery out and put it back in, the remote will fire again. Again, my testing confirmed this. So this will be the model for our remote. The physical button will always be pressed and then Arduino will just be controlling the power. Now moving over to our board, we have the NodeMCU ESP8266 connected to the breadboard. We also have this power unit on the other end that came as part of the kit. You can use the power unit. You especially should use it if you're planning on running this on battery, but you can also just use the micro USB port on the NodeMCU itself. We're gonna connect the negative from our Arduino to our breadboard, and we're also gonna connect the 3v3 pin to the positive to make sure that power is accessible throughout the breadboard. I'm also going to use two LEDs on here, a red LED to let me know when the unit is on and running, and a green LED to let me know when the button has actually been fired. The red LED will use a 500 ohms resistor, while the green one will use a 5K ohms resistor. Also take note that our pins are connected on D5 and D6. These will be important later because these are the ports we will tell our code to communicate with. Now I chose these pins by looking at this pinout reference on randomnerdtutorials.com. Now I got this working without soldering onto the remote, but I figured permanently it should be soldered. So I called my friend Moses over. One, I needed just an extra set of hands, but two, with his engineering background, I thought he'd be helpful in validating my work. We did our best. He was helpful and also distracting. And as you can see, our work was woefully subpar, but it did work. As you can see here, my multimeter confirms that there is continuity on these wires. So we're gonna connect the positive wire to D7 and the negative one to any negative terminal on our breadboard. Now that we have our hardware done, we can turn to software. First, I go to the IO page on Adafruit and create a dashboard. I need to make sure to create a momentary button, not a toggle button, because a momentary button depresses once it's let go, while a toggle button is more permanent. We also need to create a feed. A feed is the stream of data that will be sent to our Arduino every time the button is triggered. These button values here can really be anything we want, but we do need to remember them, and they do mean something. These are the values that Arduino will look for to understand what functionality you want it to do. I'm gonna pick 1 to mean the button is pressed and 0 to mean it's not. If I open my feed and dashboard side by side, you'll see that every time I click the button on the dashboard, the feed is updated. Lastly, I need to take note of my credentials. This includes my feed key, my username, and my IO key, which is like an API key or a password. My code is included in the project page, which you can find in the description. I essentially just took the examples or templates provided by Adafruit because those cover the integration and API code, and then I inserted my functions within that. First, our Arduino needs to get online and connect with Adafruit. So here in the config tab, we're gonna enter our username and our IO key. Then we're gonna scroll a little and enter our Wi-Fi information. Now I should note that this Arduino, like many IoT devices, is only compatible with 2.4 gigahertz. Back on the main page, I'm gonna enter my username again and my feed key. In my setup function, I enabled the 3 pins. Now the numbers you see here correlate with that pinout reference we talked about earlier. Then I set the default states. I want the remote off, I want the green LED off, and I want the red LED on. Now on to my loop function. Here I wrote a simple if statement. If the feed provides a value of 1, which is what happens when the button is pressed, the following things will happen. First, the remote will receive power, therefore triggering the on button. And second, the LEDs will be inversed, with the red one turning off and the green one turning on to signify that the button's been pressed. This will all last for 1 second or 1000 milliseconds, as you see in the code, and then it'll all be reversed, with the remote being off and the red LED being on. The last thing I need to do is integrate with my smart speaker. So on IFTTT.com, which is if this then that, I'm gonna create an applet. This applet's gonna be linked to Adafruit and Google. My trigger phrase is what I'm gonna tell Google to launch this action. And then I need to select my feed, the same one we selected before, and a value. Remember, throughout this process, we've been using 0 for no button press and 1 for button press. So I'm gonna choose a value of 1 and save this, and I'm good to go. Google will respond. Hey Google, turn on the AC.
Ike Broski, I got you.
I use Google Home. I think their AI is miles ahead of the competition, but you can repeat the same process for Alexa, for Siri. So that's really it. I mean, this is a functioning smart AC. Man, I invest a lot of time into figuring out how can I do less? How can I be lazier? This is my first Arduino project. I was familiar with the platform, had never done it. And now I'm thinking, like, I have my next 2 Arduino projects lined up. This project could obviously be better, so I'm already thinking about the next iterations and how I'm gonna improve it. 1, I want positive confirmation. If I'm at work and I trigger it I don't know if the AC actually turned on. Maybe something was in the way. I could put a sound sensor, which would confirm the sound level has risen. The second is temperature functionality. I can add a temperature sensor that will read the temp in the room and then turn the AC on or off to reach a target center that I have set through Adafruit. Third is a smaller footprint. I mean, this thing's big. I wish I found a smaller case. I also realized that since I didn't end up using the power module that's in there, I could use a half breadboard. I mean, this thing could be way smaller. And lastly, and perhaps hardest of all, is how do I save all the buttons I sacrificed, right? How do I tap into the controller on the remote to enable all the other functionality of all the buttons I just kind of gave up on? I don't even know where to start with that. I'm really excited to be getting back into tech hobbyism. I'm gonna make time for it. I'm gonna make time to keep learning what's happening. And I guess I'll make content while I'm doing it. So hope y'all enjoy this one. Appreciate it.